Let's see how to calculate the number of lone pairs in any geometry according to VSEPR theory. So number of lone pairs is equal to group number of central atom minus number of electrons shared by surrounding atom divided by 2. So this is the formula. Let us apply to some molecules. Let us start with the CH3 minus. Here the central atom is carbon, belongs to fourth group. Since there is a negative charge, we have to add 1 to the group number. Now it will become 5. Since there are 3 surrounding atoms, each one is sharing 1 electron. So 5 minus 3 divided by 2, which is equal to 2 by 2. That means there is one lone pair in CH3 minus ion. Now coming to another example, NH4 plus. Here the central atom is nitrogen, which is having positive charge. So we have to subtract 1 from the group number. So 5 minus 1, that is equal to 4. Since there are 4 surrounding atoms, each one is sharing 1 electron. So 4 minus 4 divided by 2, that is equal to 0. So there are no lone pair of electrons in a NH4 plus molecule. Now coming to BF4 minus. Here boron belongs to third group. Since there is a negative charge, we have to add 1 to the group number. It will become 4. Since there are 4 surrounding atoms, so 4 minus 4 divided by 2, that is equal to 0. Here also there are no lone pair of electrons in BF4 minus ion. Now coming to ICl4 minus. Here the central atom iodine belongs to group number 7. Since there is a negative charge, we have to add 1 to the 7. It will become 8. Since there are 4 surrounding atoms, we have to subtract 4 from 8. We will get 4 divided by 2, which is equal to 2. So there are 2 lone pair of electrons in ICl4 minus. Now coming to PCl4 plus, phosphorus belongs to 5th group. Since there is a positive charge, we have to subtract 1 from 5. It will become 4. Since there are 4 surrounding atoms, so the formula becomes 4 minus 4 divided by 2, which is equal to 0. So there are no lone pair of electrons in PCl4 plus also. Next example, PCl6 minus. Here the central atom phosphorus belongs to group number 5. Since there is a negative charge, we have to add 1 to the group number. Now it will become 6. Since there are 6 surrounding atoms, each one is sharing 1 electron. So 6 minus 6 divided by 2, which is equal to 0. So there are no lone pair of electrons in PCl6 minus. Now coming to I3 minus, the central atom iodine belongs to group number 7. Since there is a negative charge, we have to add 1 to the group number. It will become 8. There are 2 surrounding atoms, so we have to subtract 2 from 8 and then divided with the 2. Then we will get 6 by 2, which is equal to 3. So there are 3 lone pair of electrons in I3 minus. Now coming to I3 plus, here also the central atom is iodine but contains positive charge. So we have to subtract 1 from the group number. So 7 minus 1 is equal to 6. Since there are 2 surrounding atoms, 6 minus 2 divided by 2, that is equal to 4 by 2, which is equal to 2. So there are 2 lone pair of electrons in I3 plus. Next, XeF7 minus. Here the central atom xenon belongs to group number 8. Since there is a negative charge, we have to add 1 to the group number. It will become 9. So there are 7 surrounding atoms and each one is sharing 1 electron. So we have to subtract 7 from 9. So 9 minus 7 by 2 will become 2 by 2, which is equal to 1. So there is 1 lone pair in XeF7 minus. Next example, XeF8. Here xenon belongs to 8th group. Since there are 8 fluorine atoms, so 8 minus 8 divided by 2 will become 0. So here also there are no lone pair of electrons. Next, SiO4 4 minus. Here silicon belongs to 4th group. Since there are 4 surrounding atoms and each one is sharing an electron, so 4 minus 4 divided by 2, which is equal to 0. Here in SiO4 4 minus, there are no lone pair of electrons. Next, CO3 2 minus. Here carbon belongs to 4th group and the oxygen with double bond is sharing 2 electrons and the oxygens with a single bond, they are sharing 1 electron each. Total 4 electrons. So group number 4 minus 4 divided by 2, which is equal to 0. So there are no lone pairs in carbonate ion. Now coming to NO2 minus. Here nitrogen belongs to 5th group. And one oxygen atom which is having double bond is sharing 2 electrons and another oxygen atom having single bond is sharing 1 electron. Total 3 electrons from the surrounding atoms. So 5 minus 3 divided by 2, that is equal to 2 by 2, which is equal to 1 lone pair. So there is 1 lone pair in NO2 minus. Next example, NO3 minus. Here the central atom is nitrogen, belongs to group number 5. 2 oxygen atoms are having double bonds. So these 2 oxygen atoms are sharing 2 electrons each. And another oxygen atom which is having single bond is sharing 1 electron. So total 5 electrons sharing by surrounding atoms. So 5 minus 5 divided by 2, which is equal to 0. So there are no lone pair of electrons in NO3 minus. Next, ClO2 minus. Here the central atom chlorine belongs to 7th group and one of the oxygen atom having double bond is sharing 2 electrons and another oxygen is having single bond is sharing 1 electron. So 7 minus 3 divided by 2, that is equal to 4 by 2, which is equal to 2. So there are 2 lone pair of electrons in ClO2 minus. Now coming to another example, SO3 2 minus. Here sulfur belongs to group number 6. Here one of the oxygen atom having double bond is sharing a pair of electrons and another 2 oxygen atoms having single bonds sharing 1 electron each. So total electrons shared by surrounding atoms are 4. So group number, that is 6 minus 4 divided by 2, that is equal to 2 by 2, which is equal to 1. So there is 1 lone pair in SO3 2 minus. Next ClO3 minus. Here the central atom Cl belongs to 7th group and 2 oxygen atoms are having double bonds. So these 2 oxygen atoms are sharing a pair of electrons and another oxygen atom which is having a single bond is sharing single electron. So total number of electrons shared by surrounding atoms are 5. So 7 minus 5 divided by 2, that is equal to 2 by 2, which is equal to 1. So there is 1 lone pair in ClO3 minus. Next ClO4 minus. Here the central atom Cl belongs to group 7. 3 oxygen atoms are having double bonds. So the oxygen atom which is having double bond will share a pair of electrons to the central atom. So 3 into 2, 6 electrons plus another oxygen is having single bond which will share only 1 electron. 6 plus 1, 7. So group number is 7 minus number of electrons shared by surrounding atoms 7 divided by 2. 7 minus 7 divided by 2, that is equal to 0. So here in this case ClO4 minus, there are no lone pair of electrons. Let's go through some more examples. SO4 2 minus. Here the central atom sulfur belongs to group 6. 2 oxygen atoms are having double bonds. So they will share a pair of electrons each to the central atom, and another two oxygen atoms are having single bonds. They will share a single electrons to the central atom. So total 4 plus 2, 6 electrons will be shared by the surrounding atoms. So the group number 6 divided by electron shared by surrounding atoms, that is 6 divided by 2. 6 minus 6 divided by 2, which is equal to 0. Here also there are no lone pair of electrons. Now coming to PO4 3 minus, here phosphorus belongs to fifth group, and one of the oxygen atom is having double bond, will share a pair of electrons, and remaining 3 oxygen atoms having single bonds will share an electron each. So total number of electrons shared by surrounding atoms are 5, and the group number is 5. So 5 minus 5 divided by 2, that is equal to 0. So here also there are no lone pair of electrons. Now coming to XeO6 4 minus, here xenon belongs to 8th group, and out of 6 oxygens, 2 oxygen atoms are having double bonds and 4 are having single bonds. So the electron shared by the oxygens having double bonds are 4, and the electron shared by the oxygen having single bonds are 4. So total number of electrons shared by the surrounding atoms are 4 plus 4, that is 8. So group number is 8. So 8 minus 8 divided by 2, that is equal to 0. So here there are no lone pair of electrons in this case also. Now coming to N3 minus. Here the central atom is nitrogen, belongs to fifth group. One of the nitrogen having triple bond is sharing 3 electrons. Another is having double bond is sharing 2 electrons. So total electrons shared by surrounding atoms are 5. So group number is 5. So number of lone pair electrons is equal to 5 minus 5 by 2. That is equal to 0. Here number of lone pairs is equal to 0. Next ClO2 plus. Here the central atom is chlorine, belongs to group number 7, which is having positive charge. So we have to subtract 1 from 7. So it will become 6. Since there are 2 oxygen atoms which are having double bonds, each one will share a pair of electrons. So the total number of electrons shared by surrounding atoms will become 4. So 6 minus 4 divided by 2, that is equal to 2 by 2. So there is one lone pair of electrons in ClO2 plus. Thank you.